The time is right for hypersonics. The purpose of hypersonics is to build and fly hypersonic aircraft. We are out in front in terms of our scramjet technology, so the propulsion, but also our vehicle designs.
We believe it's going to change the way we fly. It really is about that technology as much as the application of that technology.
The other great thing about the scramjet tech that we use, it's air breathing and it uses hydrogen as fuel, so we're not creating any pollution.
What we develop here will have wide-ranging applications across aerospace.
We have this long-term target of flying at Mach 12, and at the moment, Mach 12 for sustained flight, it's kind of in the realm of science fiction. So what we need to do is break down that path to flying at Mach 12 into discrete milestones. The first of those milestones, the first flight activity that hypersonics is going to perform is DART at Mach 7.
When you travel hypersonic, the main issue is heating.
DART will be glowing red hot and 1,000 degrees, but we have to keep the sensitive electronics on the inside at under their maximum temperatures, and we don't have very much space to do that. DART is a demonstrator to fly at hypersonic speeds, but it's also to collect data and to learn so that we can keep pushing forward and make vehicles that travel up to Mach 12.
The thing about flying fast is you always end up with a really cool looking plane. We've developed this scramjet technology and hypersonic vehicle technology over the last 30 years. So it's come together, it's very mature. And then we have all these other opportunities of new materials, the commercial off-the-shelf hydrogen tech, and the computing power that we use in our analysis.
We are literally creating a new category of flight. By air breathing and not carrying oxygen on board, we're increasing the mass fraction that we're able to deliver to orbit.
Hypersonics is on the cutting edge of not only the product in terms of hypersonic flight, but also the regulatory initiative to try and integrate this vehicle into national airspace. The growth potential is tremendous.
Designing and building an aircraft that can fly to Mach 7 is hard, but we are dedicated to getting there and pushing beyond. And we're not doing that alone. We have a very wide hypersonic ecosystem of partners.
We've got the best partners on the planet to help us do that. We're dealing with partners such as Kratos, DIU and Rocket Lab.
We also have a lot of smaller companies here in Brisbane, but also throughout Australia that help take our tech from the design to the real physical thing.
In order to fly at Mach 7, we need to overcome a whole bunch of engineering and materials and technology challenges, and what we're working on at the moment are tackling those challenges one by one.
We've got the team, we've got the technology, and we've got a way of being able to build what we build in a high cadence. And I think that's why organisations like the Defence Innovation Unit, that's exactly why they deal with people and companies like us, because we can move a lot faster.
The goal at Hypersonics is not just to enable hypersonic flight, but to commercialise it for everybody.
It's for the planet. I think we're building a platform using hypersonic technology, particularly scramjet, that are hydrogen powered, and we're looking to deploy that technology across various aerospace applications. We see the planet as the beneficiary of what we're doing in the longer term.
No, it's never easy, but that's what makes us unique, and that's what puts the X in hypersonics.